Question 8. This question is about equilibrium mixture form when A and B react. Delta H is negative 32 kilojoules per minus 1. A is just 1 mole, B is 2 moles, C is 1 mole. A solution containing 0.6 moles of A is added to a solution containing 0.6 moles of B. Amount of C formed at equilibrium is 0.28 moles. Reduce the amount of moles of A and B in this equilibrium in this mixture equilibrium. So, like I always like to do, the ice method. And then once you go into mole fraction partial pressure for Kp, then it's ice and P. But so we've got A, B, and C. I is initial moles, C is changing moles, E is equilibrium moles. We know a solution contains 0.60 moles of A. Add to a solution containing 0.60 moles of B. The amount of C formed is 0.28 moles. Now we're going to assume the amount of C in the initial mole is 0. So we've added 0.28. Therefore, on the left hand side, we're going to subtract 0.28. However, this one is 2 moles. And this is 1. So what we're going to do, we're going to times that by 2, and we're going to subtract by 0.56 instead. So 0.60 minus 0.28, 0.32. 0.60 minus 0.56, 0.04. So the amount of A at equilibrium 0.32 and amount of B at equilibrium 0.04. Given an expression for equilibrium constant Kc, Kc square brackets products of reactants square brackets product C over the reactants A the square brackets and B, but because we have 2 moles of B, it's going to be squared. Just remember square brackets and products of reactants. 8.3, the temperature is decreased. Predict the effect, if any, on the value of Kc. Well, we know only temperature can affect value of Kc. Same with Kp, but we're not on Kp, this is AS level paper, that's in year 2. So for Kc, if the temperature is decreased, well, we know delta H is negative, so therefore the forward reaction is exothermic. So if I increase the temperature, equilibrium would shift in the left hand side to oppose the increase the temperature, the endothermic direction, the left hand side, opposite direction. However, because I'm decreasing the temperature, it's going to shift to the right hand side to oppose the decrease in pressure. Increasing the pressure is going to shift in the forward direction, the exothermic direction. And so what will happen to the value of Kc? Well, we're going to have more moles of C, so we're going to have more products of reactants, so we're going to have a bigger number of C. And if you think of it like this, if let's say this original equation is 100 divided by 10, if we increase C to 110 divided by 10, what happens to the value of Kc? Well, Kc in this is 10, Kc here is 11, so Kc increases. That's just a random example, just so you guys, I hope you understand. But what happens to the value of Kc? Kc value increases as equilibrium shifts to the right hand side, exothermic direction, to oppose the decrease in temperature, hence increasing the temperature, therefore as more moles of C, bigger value divided by same value means a higher value of Kc. And then 8.4, this is the mixture equilibrium. This is the mixture equilibrium. A is this, C is this. For this reaction Kc is this, calculate B at equilibrium. So we're going to use this constant, and we're trying to find B at equilibrium. So we know B squared equals C divided by A times by K times by KC. So B squared equals, are we given volume? No, we're not. This means calculate the concentration of B at equilibrium. So it's going to be 0.62 divided by A, 0.48 times by KC, 7.8. That's for B squared. So therefore to find B, it's going to be square root of that. I'll get B as 0.407 . So let's go through it now. Question 8.1. Moles of A 0.32, moles of B 0.04. Kc, C in square brackets of A, B squared. Remember, square brackets, products of reactants. This one, Kc increases, equilibrium shifts in the right hand side, axiomatic direction. And then therefore we're going to round B to 0.41 to two significant figures, because if we look at the other moles of A and C, they are also to two significant figures. Therefore we need to round B to two significant figures for the final mark. And that is the end of question 8.